Welcome back, students. In the last section we were discussed about the terms related to spherical mirror, and in this section we have to consider the rules for image formation by a spherical mirror. To obtain the nature and characteristics of image formed by a spherical mirror, first we have to discuss about the rules for image formation. That means to obtain the particular image by this concave and convex mirror, first we have to learn about the rules or certain conditions of image formation. That means the light rays from that object will fall on the spherical mirror in different ways, and after reflection, by obeying the law of reflection, these light rays are reflected back, and it is unable to predict where these light rays will move after reflection. So in case of these spherical mirrors, there exist certain definite situations in which the reflected light rays will follow a definite path. That kind of 4 conditions are there for this spherical mirror. That is 4 definite conditions for concave mirror and 4 definite conditions for convex mirror. That is, here we are going to consider the rules related to the image formation by spherical mirror. During the reflection, whether it happens from a concave mirror or a convex mirror, the law of reflection is always valid. That is already we mentioned, whether the reflection is regular or irregular, law of reflection is valid. In the same way, if the reflection is taking place from a concave surface or a convex surface, the law of reflection will be always valid. That is, the angle of incidence should be always equal to angle of reflection. In case of this spherical mirror, that is in case of this concave mirror and convex mirror, in order to measure the angle of incidence and angle of reflection, we have to draw the normal line, or we have to consider the normal line at the point of incidence. For a plane mirror, it is very easy to consider the normal line because we have to draw a perpendicular line at that particular point of incidence. But for this kind of a curved surface, how we can draw a normal line? It is very easy to draw a normal line to a curved surface. That is actually the property of a sphere, and the curved mirrors or the spherical mirrors are actually part of a complete sphere. So if we are considering a sphere, and from the surface of that sphere, if we consider any point, and if we draw a perpendicular line or a normal line to that point, that particular normal line should meet the center of that sphere. So it is very easy to draw a normal line to a curved surface. Just we have to draw a line from that point to the center of that sphere. In case of spherical mirror, it should be meet at the center of curvature. So at any point of incidence, we can easily draw a normal line. Just from that point to the center of curvature, draw a straight line. That will be the normal line at that particular point. Then if we know the normal line, it is very easy to measure the angle of incidence and angle of reflection. The 2 angles will be always equal in any type of the spherical mirror. So directly we can go to the conditions or rules for image formation by a spherical mirror. So for concave mirror, 4 conditions are there, or 4 rules are there, and for convex mirror, 4 rules are there. So first we can consider the rule number 1. In case of concave mirror, if the incident light ray is parallel to the principal axis, then after reflection it will move through the focus of that concave mirror. That is, if the light ray is parallel to the principal axis of the concave mirror, then after reflection that light ray should move to the focus of that concave mirror. In case of convex mirror, if the incident light ray is parallel to the principal axis, then after reflection it will move, or seems to be diverging from the principal focus. That is, if the incident light ray is parallel to the principal axis of a convex mirror, the light ray seems to be diverging from the focus of that convex mirror. Convex mirror is already we mentioned that it is a diverging mirror because light rays are diverges to different directions, and if the incident light ray is parallel to the principal axis, after reflection it seems to be diverging from the focus. Number 2, for a concave mirror, if the incident light ray pass through the focus of the concave mirror, then it will move parallel to the principal axis after reflection. That is, if the incident light ray is passing through the focus of that concave mirror, then after reflection that light ray must or should move parallel to the principal axis from the point of incidence. For a convex mirror, if the incident light ray is directed towards the focus, then after reflection the light ray moves parallel to the principal axis. For a convex mirror, the incident light ray directed towards the focus. Why it is considered as directed towards the focus? Because for a convex mirror, focus lies behind the mirror. So it is not possible to consider a light ray passing through the focus. So we have to consider a light ray directed towards the focus. Then if the incident light ray is directed towards the focus, then after reflection it will move parallel to the principal axis. Rule number 3, for a concave mirror, if the incident light ray pass through the center of curvature, that light ray returns back after reflection, or it retraces the path after reflection. That is, if the light ray is coming through the center of curvature of that concave mirror, after reflection it bounces back through the same line through which it strikes the mirror. For a convex mirror, if the incident light ray is directed towards the center of curvature, the light ray bounces back or retraces the same path. Here also, why it is considered as directed towards the center of curvature? Because the center of curvature of a convex mirror lies behind the mirror. So it is only possible to consider a light ray which is directed towards the center of curvature. And if the light ray is directed towards the center of curvature, it retraces the path or bounces back the same path after reflection. Rule number 4, for a concave mirror, if the incident light ray strikes the pole of that concave mirror, it reflects back by making equal angles with the principal axis. That is, if the light ray strikes at the pole, it makes an angle with the principal axis and it bounces back by making equal angle with the principal axis. convex mirror, if the incident light ray strikes at the pole, it bounces back by making equal angle with the principal axis. That is, the incident light ray makes an angle with the principal axis when it strikes the pole, and it makes an equal angle with the principal axis and bounces back. These are the basic 4 rules or conditions for spherical mirror. Using these conditions, we can obtain or we can draw the diagrams for image formation and identify the characteristics of image for these spherical mirrors. So just once again we can mention about the 4 basic rules. First one, if the light ray is parallel to the principal axis, for a concave mirror it pass through the focus after reflection, and for a convex mirror it seems to be diverging from the principal focus. Then the second rule is, if the incident light ray is directed towards the focus, if it is directed towards the focus of a concave mirror, after reflection it will move parallel to the principal axis. And if the light ray is directed towards the focus of a convex mirror, after reflection it seems to be diverging parallel to the principal axis. Rule number 3, if the light ray is directed towards the center of curvature, for a concave mirror and convex mirror it retraces the path, or it bounces back after reflection through the same path. Then rule number 4, if the light ray strikes at the pole, for both the concave and convex mirror, the light ray bounces back or reflects back by making equal angle with the principal axis. That is, what is the angle made between that incident light ray and principal axis? It makes the reflected ray also makes the same angle with the principal axis. These are the 4 conditions or 4 rules for the spherical mirror in order to obtain the image